for attending. How's PyBay going for y'all? Good? Yeah. Last session of the weekend, and hopefully you had a pleasant time, like networking, learning new things, and also learning this last thing, which we'll be talking about A/B testing in Python. And if you want to follow along, zoom in a little bit, you can just head on to this link right here, a bit.ly link, Raul-A/B testing, or you can check it out later. It redirects to a GitHub repository, and it will contain a Jupyter notebook with solutions, and then Jupyter notebook that you want to try to implement yourself. Yeah, and they're just additional resources and other information alongside in that repository. So yeah, to what Vikram was saying earlier, I'm a data analyst at Autodesk, volunteer for Delta Analytics, PyBay, do like a lot of side projects, and I enjoy coffee and running on the beach. Yeah, and also like to do other physical activity just to relieve some stress, right? that's always good to do. Healthy habit. And today you'll be learning about A/B testing from more than just an academic approach. You'll be understanding some of the implications of performing A/B testing from maybe like a business sense or in production essentially. And just a note that a lot of this information covered is not affiliated with Autodesk at all, particularly the concepts and then also examples not discussed. They're more geared towards this individual session and as a tutorial kind of like format. And yeah, and if you're following along, there's just like a couple of notes to make sure that you're A-OK within your own reproducibility of going through this Jupyter notebook. So conceptually, what is A/B testing? A/B testing is the randomized experimentation between two variants or two groups. More traditionally in academia, or when you're in Stats 101 course, you're trying to test between a control group and a treatment group. The treatment group being the somewhat different group in comparison to the initial group that you made a change on, and trying to see if there's a significant difference between these two things under the assumption that there is no difference between these two groups. And then, so say for example, we have a digital ad campaign A, and we have a call to action, or what I would put more visually is like a button that says learn more here, or excuse me, click here please, or something of in a notion of trying to get you to act on the particular ad. And then you have an alternative ad campaign B with a slight modification for that same format. A visualization would probably have been better, but just imagine there was a text change, alteration. You're just saying okay, learn more here. And examples of in consideration of the cases I want my users to click on my ad so they can learn more about our product and hopefully reach to my overall objective. And within that, there'll be a metric of choice defined as a click-through rate, which I will talk about later, and how we go into that decision as we go through this A/B testing process. Just a quick background before proceeding to the more specific details. Alan Downey, he's a researcher at Google currently, defined A/B tests in a blog post, more generally hypothesis tests, in the following construct. Abstractly, it's you have your data, simulated data, your notion of a null hypothesis, or H0, or H subscript 0, and that model of H0, or H0 is saying okay, there's no difference between these two groups. We compare these two sets of data or samples or variants, and we do a calculation of a test statistic. We'll go more about that later. And then with the test statistic, we try to compare between the observed effect or some critical value to see if there is a difference between the two groups. And we'll kind of go more about that later, but you kind of see a quick example of what that may look like going forward. And then hypothesis tests, I mentioned what are hypothesis test, even though this discussion's on A/B testing. A/B testing is essentially hypothesis testing, but the difference can be defined by like a lot of researchers or individuals in industry. They're like, well, they're different based on their experimental design. But at the core of everything, in particular of the setup and everything in the processes you're doing, considerations, its roots come from that statistics background and born within hypothesis testing. Here, you just see like A/B testing essentially is the modern version of a hypothesis test. And like in Stats 101, when say you may or may not have gone into those curriculums, you learn such basic concepts as the mean, standard deviation, variance, descriptive statistics, and you lead on forward into hypothesis testing, and you're like in this, you're confounded, like kind of confused, and like what the information, what does this all mean? What does the hypothesis test mean? And like the subtle assumptions, differences from that. And also you get to understanding of like, okay, how can I go about in choosing the right test statistic? So there's a lot of confusion there. And like as per learning learning anything, there will be some sort of confusion here. But in this session, hopefully I can make that learning curve a little bit easier, or just like make things more simplified too. So that's just like a little bit of background. And then here's just also some cases of like, oh my gosh, what test statistic or what test do I need to approach for, depending on the different types of use cases that I have under given my data's distribution, which you're like, holy cow, what does Gaussian mean? Right? Binomial, Poisson, and a multinomial. And then also you have the considerations of your data, like is it categorical, non-categorical, right? A lot of this information I would have liked to talked about in the session, though, given the time frame that we have. That can be talked about like later on, or if you want, since you have, you can go into that the GitHub link from that Bitly link that I created, submit a PR or an issue, and have forced me to mention that, and I'll add that to the documentation of the repo as well. So I encourage some collaboration as well as you learn more about like A/B testing and hypothesis testing. Okay, so let's go back to the format. So we had data, simulated data, and we come under the initial assumption of there is no difference between the groups, test statistic, and then we go through like calculations. But then more specifically now getting to like the crux of everything. So we'll go into the process of an A/B test. Using that same example of digital ad campaigns under some like dummy data. But the steps that we're going to go through is like we're going to state our hypothesis, have some assumptions, both basic and statistical assumptions. Talk about like the distinction between those. Define like define and collect your data and how you'd collect it, and then some other preceding assumptions like minimal detectable effect, simplify size, so much, so forth, to analyze. Then we'd actually analyze or perform that test statistic calculation right about here. And then we reach some conclusion for this A/B test. So here, state your hypothesis. There are different types of hypothesis statements, there are three different types of declarations for your statement for your hypothesis test. See if I got it here. Cool. So you can have your original assumption of H naught being like seeing that there is no observed difference between the two groups or two things you're comparing. And then the three other permutations for your alternative hypothesis, which is that the alternative hypothesis is a statement of like, okay, there is a difference between like these two groups or these two controlled treatment groups, depending on like the context of the construction of your A/B test. You can have something like something's less than equal to some value, something which is the difference between our two soon-to-be click-through rates would be greater than or equals to 0, and then there is these differences are not equal to each other. And visually, what that would mean is some critical value is just our test statistic calculation is greater some critical value, or there's a right tail test, kind of simply, where the information here for the right tail test, we're saying that, okay, some value is greater than the differences between these two groups. Right here, we have a left tail test saying that there maybe something's like the difference between these two is like less than some like critical point. And then right here is there might be a difference between these two groups in either direction. And we'll be gravitating more into this approach just because when going into an A/B test for like individual campaigns and doing some new self-discovery, unless we have some information on like what direction that we're trying to test for, then we can go through and like evaluate for left or right tail test. But here's like more a neutral approach of like saying, okay, like are we trying to see at least if there is a difference between these two groups that we have. Okay, and then some implications for your hypothesis test. Your statement of your hypothesis test is you want to ensure that you're not trying to prove that there's a difference between two things, but rather you're under the initial impression, as I mentioned before, that you come in expectation that there is no difference between the two groups and trying to observe if there is a difference between these two groups. And an analogy to that is imagine you're going to a courtroom and you see Judge Judy and already she's just like, oh no, you're guilty. And depending on who you are, that reference may be relatable, depending if you watched Judge Judy or not in the past. Here are some different cases of like what would be the reality of what you decide, of what you would decide versus what you would decide in your A/B test. And there are 4 different types of cases. I'll come back to the visualization real quick. But we have a point of a type 1 error where we say that, oh, something was true in reality. It was that wasn't the case. We have a type 2 error, which is has more negative connotation to that, where say that for the comparisons to our 2 campaigns, that we say there is no difference between these 2 campaigns at all. But in reality, there was a difference, but we don't go towards the conclusion of that alternative hypothesis in our test. And that's a type 2 error because we're standing firm with our own beliefs, even though there is some evidence in this particular test that there is an observed difference between these 2 groups. And then here is, right here would be your power calculation. Right here would be like 1 minus beta, which would be like 1 minus your probability of a type 2 error. And more visually, what that kind of like showing here, so we have a distribution where H0 is like assumed to be true, and then there we have a different distribution where H1 is like assumed to be true. And at this like cutoff point right here, we see are we trying to determine from our initial hypothesis is there a difference between 2 groups? This here is our alpha value or the probability of that type 1 error. Right here is the power, which is set to 80%, which is something more that we do like that we try to like focus on, which is the probability that if we reject something, it actually is the null hypothesis is false. Or if we go say that there is a difference, like that actually is true, and the power is like more focused and important within a test than like the alpha value or the false positive, the probability of false positive. And then here, I wish I can like probably color this actually. This portion right here would be that beta or like a type 2 error, and then like here's just like that 1 minus like alpha area. Okay. And so now we like stated our hypothesis and kind of like had kind of undergo the implications, like what our hypothesis, what would happen in certain cases and the results from our hypothesis test. We need to have some statistical assumptions before going preliminary and before going into the actual calculation, which the core things, one would need to understand their existing process, how everything works functionally, the scenario that we are trying to tackle, or trying to look at. So right here, we have two ad campaigns, A and B, different calls to action or different texts for like some ad. And we need to understand the type of data being collected. Here's just like a sample like data set where we have the information we're collecting from our system, or however we're collecting our data is we have like a date or timestamp, more particularly depending on the setup of your system, your campaigns, the user, and their action if they clicked or did not click. And this is like a binary case where the only two values that can exist in this for an action is a click or not a click. Okay, and then we need to understand from the scenario, what's our goals, what's our intentions. So a lot of times in the industry or from like stakeholders that you're trying to perform this test for, they just want to ensure like for the overall objective, we need more money. I was gonna put a SpongeBob, Krusty Krab, money meme on here, but I felt like I was like a little bit too generic, so I added a different SpongeBob meme where the crux of things. That was the second alarm. Where more specifically where we want to get to, rather than just like trying to investigate what ad would probably give us more money, we need to go more into the understanding of, okay, how can we tackle a more specific object to hopefully in downstream or kind of in result get to that overall objective of getting more money or trying to reach more money for the conversions we had from our ad. You know, with that being said, for what we're trying to do for our ad campaign, we're trying to see like the usability of it, of a person clicking or not clicking. So here we're gonna use the click-through rate as our calculation preliminary mentioned. As opposed to other metrics of choice, something like a conversion, retention, bounce rate, and so forth, as different metrics of choice. And the reason for that is just it depends on the question, the type of question you're specifically asking and trying to solve for specifically in your A/B test. Okay, and then there's the discussion of the metric of choice, like I mentioned. But then what's defined as a click-through rate is the total number of successes or the total number of clicks divided by the total number of events, which is the total combination of clicks and no clicks, or total number of impressions, depending on the type of system you're working on. An example, Google Ads has just like impressions column and clicks column right off the back within like when you're trying to see the overview of particular campaigns. Different systems might be different depending on the construction and layout of their UI and what they're trying to show for metrics. Okay, and then now let's go into like the basic assumptions. Every event has to be independent from one another. When you're going through and doing this A/B test on users, making sure that your samples are, your campaigns are being randomly assigned to users. So you have some true random sampling occurring. And then to avoid like some type of like bias or like imbalance in your assessment, going through and comparing these two campaigns. And we most importantly need to understand and assume the essential limit theorem is applied. So for some given population of information of like a large amount of data points, for like the samples you collect from that population, regardless if it has that bell-shaped curve or normal distribution, or if it does not, for the samples that you collect from that population, the larger size or the larger the data points within the samples, they reach some normality. And that's one of the important assumptions that we have right here as the understanding of the essential limit theorem, and then like assuming that within proceeding into your A/B test. And then here's some like other remarks, like segmentation. Be careful not to target two specific types of users, because say in your A/B test, you like for different permutations of segments that there is a difference between the two groups depending on your segment for every A/B test you run on those particular segments. But when you add them all up or do the overall A/B test on all people from all your segments, your test mainly comes out as like, oh yeah, there is no difference between the overall collection of overall samples you drew from that population. Just be aware of like your segmentation, and this is due to the Simpson's paradox. The more details on that, like at the very bottom is the Jupyter Notebook, so you can check that out in your own time later. Here now we go down into some imports, and then some last kind of assumptions or like preliminary calculations we need to do before actually doing the test statistic calculation. One is identifying your minimum detectable effect or your practical significance separate from the statistical significance that we are initially trying to observe. And like when I say practical significance and statistical significance, there is a difference there. From business standpoint, if you're like the information you're collecting, you know the data a lot, and you see like quite frequently that information or the campaigns may be different based on the A/B test you're trying to draw from. Well, based on the preliminary like past history or business knowledge of information, maybe it's not practical to change and go for the alternative case or the new campaign. In this particular case, you would want to go for. And that's because that can be due to reasons like change management costs within trying to coordinate that change of a new campaign. There's like some other like business justifications to that. So just remember, though something can be statistically significant, is it practically significant? And that's kind of like estimated by your minimum detectable effect. Understand that your sample size is important as well. So if you collect a small amount of information, like and run an A/B test, you're like, oh hey, yeah, like there's differences between these two groups. Your sample size matters in the confidence that you would have like in the results of your test. So the more data you have, the more power or like you would have in your test as well, which would be if we were, still under the impression that there is no difference between two groups. If there is a difference between these two groups, and like it's actually true. Oh yeah, so if there's a difference between these two groups, and you know that's actually the case, then we've gained more power there for more samples. And here's just Costco samples as a like depiction of your consideration of your sample size. More is better, especially at Costco. And so here's a formula for one particular case, our case for calculating the minimum detectable effect. And then also the soon to be associated sample size that we would need to collect for both groups. Since we don't have a lot of preliminary information here, but what we do have is coming forward and at this point of the test, or preliminary to the test, is we have our click-through rate for the existing campaign, which is denoted as this P hat here. And then we can make an estimation of what our minimum detectable effect would be based on, you know, our past experiences or what we feel like is significant practically, right? So something we're still missing right here is these n values for both groups. So assuming the collection of your information for both groups is, assuming the number of observations you're going to collect for both groups is, just about the same. We can get like an estimate. We can set these p-values equal to each other to like, instead of being like p subscript 1, p subscript 2 for respective groups, we can just have them just be p hat. Do little transformations using some mathematics and reaching to a point where we can get our sample size for one individual group. But then remember, we have two groups, so we would want to add. We just want to like double it. So adding this two together, like n1 plus n2, we reach this like calculation right here. And let's just go into a quick example right here with that, like what would that calculation would look like. So let's say like our t statistic estimate is about 2. The reason why I say 2 is because since we're going to be using an alpha value of 0.05, the t critical value, which you'd see later on, It's about like 1.96, or 1.96, and then we just like round this up to 2 for a simple case. And then let's say the original campaign's like click-through rate was about like 51%. Okay, and then we were like, okay, what we think is practically significant in the difference of these two groups, we'd say about like about like 5% difference, absolute difference between the two groups is just about right for it to be like for them. If these two groups are different, it'd be like practically 5% different. And here we just do a calculation of everything that's exposed to right here. So 4 times that P estimate times 1 minus that P estimate, and then do this real quick. This is taking the something to the power squared. You can also use NP like a NumPy function to get the square of something or some exponential value. Come back here. This T value divided by our minimum detectable effect value, which would be T is 2. MDE is 0.05 as stated. 0.05. Yeah. Cool. Yeah. Thank you. So T estimate would be nothing. Thank you. Yeah. Cool. Okay. So thank you all. So we see for our sample size total for both groups combined to be like around 1,600. Luckily, online on the internet, there are sample size calculators available to you, courtesy of some businesses or personal projects from other individuals. From some companies, Optimizely and VMO have their own sample size calculators. But Evan Miller, a person that develops some statistical tools and posts them online, has one available on his website, his personal website. And you can just enter in your information and get like an estimate of like what your sample size should be like per variation. So here we have a base conversion rate of 51%, seen before right here, that for that campaign A. As click-through rate, the minimum detectable effect that we want to see, 5% difference, absolutely, to get that sample size. Okay, so it's just, okay, set that sample size equals 1,600. And then understand that within going through the A/B test, your duration matters. So say we have 20,000 observations between both groups, and we know that 4,000 unique users typically flows in per week within the system. We would have to like wait for like 5 weeks for our test to run. It's like, yeah, 5 weeks for our test to run, assuming traffic flow is like a steady stream for the campaigns being exposed to users. And if you test, if you extend your test out like too far away, or have your test like you stop your test too early on, you can lead to the possibility of incorrectly going through within your A/B test. So that's something definitely to note. Data collection setup. Be aware of your system and how it's set up, and understand the potential vulnerabilities around that, or if there are any vulnerabilities around that, depending on changes back, so to speak, with either like the construction of the campaign or how the information is being served up, that campaign is being served up. For example, in a Google ad campaign, if you come against a policy issue, or just like any online advertising platform, if you come against a policy issue, your campaign would either be paused or deactivated. And say if like your other campaign is still running, and you, I wouldn't say ignorantly, or just like kind of go maybe along and still do a test, and you're like, oh yeah, there's a significant difference, statistical significant difference. That may be not the case, because something's being affected either in the test, the campaigns themselves, or like the system itself. And there's like more like specific things about like system items I can like talk about later on. And to ensure that the system is fair, we go through something called like AA testing, which is for one of the groups that we have, or particularly the initial campaign A that we have, or control group. We test it on itself to determine if there's a statistical significant difference. If there is, that shouldn't be the case. Whenever you're like testing something, like when testing a group against itself to see if there is a difference between itself, there shouldn't be a difference. Right. So that's just something a consideration when going through the setup of your data collection. Here is quite a few functions to generate the dummy data that we would have. I should have probably add some comments, but here what's happening is we have a campaign period calculation for start and end date. And particularly, I just chose the beginning of July to kind of like today. So we have that there. For generating some dates, the data set generator to get the actions, your dates, a fake email of a particular user that may come up in your experiment. And then from there, there's a transformation of the data sets you have to creating a data frame or data frames of these two groups. Just to note, this data collection, these functions for generating your data doesn't have like all unit tests. A lot of things can like make or break you when you're trying to like run something different. So just be aware of that. And then it's probably something we'll have to add later if you submit an issue. Let me know, and I can just like add the documentation for these particular functions. Okay, and then here's just a distribution, a function, a plot of a distribution coming up pretty soon between our two groups. So here we calculate. I should probably actually run these. Okay, so and then right here we have our two campaigns. Let's just call them person doe 1 and 2. We generate the two data sets, combine these two data sets, and then ultimately get us a data frame or two particular data frames for each of our campaigns. Pardon. I'm just going to run everything. Cool. So where was I at? Cool. So I think the kernel's on. I may have to restart my kernel. This is the fortunate woes of going through and using a Jupyter notebook. Run all blue, run all cells. Yeah, run all cells. That works. Doesn't, just have to go to the solution portion. Oh yeah, it looks like it ran. Okay, cool. Coming back. So we have our generated our two data frames. And so right here, just to do a quick check to confirm that these, what the output of these data frames will look like, I'm just gonna output the first initial rows of these three data frames. For our pandas data frame, we have a function called head or tail to identify the first 2 or 3 rows of it, 3 rows of the data frame. Go right there, and we identify where our schema looks like of these data frames. So we have a date, campaign, click or no click, and this is a transformation from the action column that pre-existed. Here we have our go through our calculation of our campaign click-through rate. Let me just go to solution section real quick, just because kind of running out of time. Have to like do a slide through it. Thank you. Right about here. So within our click-through rate calculations, we have the total number of successes which is that click column divided by the combination of no clicks and clicks, which is our total number of impressions. So the successes divided by the number of observations provides us our click-through rates for both respective campaign data frames. And here we see the distribution of this of both campaigns respectively for campaign 1 and then campaign 2. And you see like a 10-set normal distribution as our sample size gets bigger. If I were to use a sample size rather than 1,600 per campaign group and use something like 160, you would see a different type of distribution. But remember, applying central limit theorem, we approach that like normality. And then here we calculate our proportions again. So click-through rate for campaign 1 is about 50%. And then for campaign 2, the click-through rate is about 53%. And you see our total number of impressions. And that's just so far what we have created is the metrics of choice so far. Now we go through in the T-statistic calculation, which we use this decision of a calculation by proportion or test of proportions for this particular T calculation. There are other types of T calculations dependent on for your two groups. Is the variance equal? Or are they not equal? Then we'd have to like shift into an alternative formula. There's some notes about that at the bottom as well in its own section. And then here we calculate the difference between these two click-through rate proportions divided by the standard error. The standard error is the standard deviation of the samples that you have collected. And then just note particularly for a T-statistic calculation that there's some degrees of freedom or considerations factoring into your calculation as well when going through into analyzing your results. So let's through code, let's kind of like identify that process distinctly. So originally, as we saw earlier, we calculated our proportions based on the two respective data frames of like getting the sum of no clicks and clicks for the total number of impressions, N1 and N2, and then our and then getting the CTR click-through rates for the CTR falling respectively. So the number of successes divided by that total number of impressions. Take the difference of these two click-through rates as seen in the formula above, just like right there. And here we calculate the individual terms within that standard error calculation right here. And to calculate our standard error, which is the square root of this term and equivalently this term, but for the second campaign that we have. And here we calculate the test statistic, which is that difference mentioned earlier divided by the standard error. And then here we have our degrees of freedom, which is the total number of observations in the first campaign and plus the second campaign minus 2. And that's equivalent to like n the observation minus 1 plus the second group of total impressions minus 1, and the sum of those. And then here we calculate our critical value, respectively a confidence interval, and lastly, we calculate our p-value within this function as well, and have the consideration of for our p-value what our calculated test statistic is, and the degrees of freedom, and multiply it by 2. And the reason why we're doing this right here for we're using a two-tailed test, so we're taking the absolute value of our t-statistic for the calculation of for what would be the area under like a one-sided t-test, multiplying it by 2, to get us like the total area or coverage of the p-value. And here we have the outputted results printed out coming forward after we implement this function. And yeah, I know I said a lot. Thank you for bearing with me and going through all of this. It's all been a pleasure going through and going. The kind of like more the cruxes and specifics of an A/B test. Here we implemented our function. Okay, and everything already ran already, but we have our group 1 and group 2. The alpha value, which was 0.05, stated previously. And we want to output both the calculations and our conclusion. And if we go down to the analysis, we see our alpha value was 0.05 and a p-value of 0.11. We have our t-statistic, which is 1.59, a critical value t-star of 1.65. And just have this in your mind. And then as we go about making a decision for this A/B test, we fail to reject the null hypothesis because of it can either you can observe this in 3 different ways. It can be due to you can have a p-value, the p-value that we calculated, 0.11, which is the probability of looking out probability of observing a value as extreme as likely as the one you're comparing to, assuming the null hypothesis is true. So that's what the p-value is. If that p-value is less than our alpha value or our probability of a type 1 error, then we can reject the null hypothesis. That's one standpoint. Another thing to look at is, okay, if our critical value, if our t-statistic is greater than our critical value that we established, then that would be, then we can say we can reject the null hypothesis and go for the, and then make a decision for the alternative hypothesis. And then as a more recent, a lot more people are saying like, oh, hey, well, you should also look at the confidence interval as well to determine and evaluate if for your the decision of your A/B test, should you or should you not reject your null hypothesis. And that's something that's trending in as a more of a focus within A/B testing and hypothesis testing. And then kind of like more simply, in comparison to everything I've done in my manual approach, SciPy, a library in Python, has the availability of a function to quickly calculate your t-test for you. And specifically, we use SciPy stats t-test of independent in comparison between 2 independent groups with assumed equal variance, which was what we assumed previous. Then we can straight off the bat get like a calculation of our t-statistic and our p-value. And here is like 0.09 and with a t-statistic. And here if we make a decision based off that calculation of the SciPy's function, we still fail to reject the null hypothesis. But if you noticed, between my manual calculation and the SciPy calculation, there were some differences in both the p-value and t-statistic, just like subtly. And it comes back, now we come back down to the idea of how you construct your A/B test, how your methodology is, and what the construction setup of how you're going to go in your approach. That's something important in going through with the A/B testing. Just because you reach a certain result, if you're trying to determine, or excuse me, if you see difference or no difference, it's good to reevaluate and see if there's reproducibility of your results to some extent. And so it's always nice to keep in mind that you should always be testing. That's critically important. And you should also be humble about going about with your A/B testing, trying to determine if observe if there's a difference in something leads you to some sort of like a confirmation bias and trying to prove something either for yourself or your stakeholders, and which has been more predominantly been the case for organizations that haven't had the luxury and forethought thinking of how to set up your organization or team from like in a state of like an experimental design and how to like really think experimentally, so to speak. There are some other considerations I wanted to mention. I'll just quickly highlight. So just keep in mind p-hacking, making sure when the test occurs and when it should stop, making sure it's making sure to have that test and be implemented until that expected time frame. Don't peek in your test. You know, if you look and you're like, oh yeah, it's like something significant midway in your test, overall coming down to the end of your test, that might actually not be the case where there is no difference between the two groups. Your sample size matters, and then there's some other items and caveats within going through an A/B testing. Right now, I am kind of running out of time, so if you have some free time of yourself and you want to like check this out openly again, as I kind of like recommended ad nauseum, check out the GitHub link, and if there's any issues, just like feel free to submit a PR on your issue. Hopefully you've learned quite enough and you have like more insight into A/B testing from like both a like research point of view, but then also from like a business perspective as well. Yeah. Any questions? Yeah. Oh. Yeah. Thank you. Should probably do that. Yeah, so it's in a form of a bit.ly link. Bit.ly, and then just, for the ending portion of that link, just Raul-A/B testing, or if you all want to take a picture right now, you can just take a picture of that. Yeah. Yeah, most definitely. Yeah. Oh, so the question was, where would I, as an individual, go to find these resources and determining like what test statistic to go about in my calculation? You can go about, not like, first you have to have the understanding of like your distribution of your data, the data types, like some like little caveats and considerations of your data, to then go through and making your decision for like what test statistic to get them to determine. And some resources that are available, for me, it was like a bunch of blogs, particularly from Optimizely, VMO, Google Optimize, which are all A/B testing platforms. Which it's like a quick way of like doing A/B tests without you having to, as an organization, to code out that information. And towards the end, I have some like resources available to determine that. But then it's also, it really comes down to the bottom of it. It's just like understanding, like doing some preliminary research in the of like what test calculations are out there and like what to consider based on the pre-existing assumptions I just mentioned. Okay, yeah. Thank you.